Good morning, everyone. My name is Ru Yan. Today, I'm going to present our paper, Chromaticity Gradient Mapping for Interactive Control of Color Contrast in Images and Videos. It's joint work with my collaborators, Jiatian Sun and Abe Davis at Cornell University. In this talk, we'll start by looking at a technique that artists have used for hundreds of years to convey high contrast scenes in low contrast media like paint and canvas. We then analyze the technique mathematically and see how we can reproduce it in an image editing tool. Does this work better? Okay. And based on this analysis, we designed an interactive tool for applying and controlling this technique in digital images and videos. So let's start by looking at why it's hard to convey high contrast scenes in a painting and how artists have made clever use of color to address this challenge. The real world is full of visual content that spans an numerous range of brightnesses. In an outdoor scene, for example, a sunny patch of the sky might be thousands of times brighter than a shade. So we might quantify this by saying that the outdoor scene has a dynamic range of 5,000 to 1, which means that it is often impossible to capture the contrast of a real scene in a painting. So how have artists tackled this challenge? Two examples we examined in our work are chiaroscuro paintings, which focus explicitly on high contrast scenes, and impressionist paintings, which often focus on compressing the contrast of lightness in a scene and converting it to strong color contrast. Let's take a close look at this chiaroscuro painting. The brightest part of the scene is the candle, which in real life should be much brighter than this patch of the night sky. But instead of representing this contrast using brightness, the artist used different color tones here. In the foreground of the scene, we see that these different color tones are used for details in the light and shadow of our candle. We can quantify this by saying that the artist has taken contrasts that would normally be represented by differences in lightness and instead represented with differences in chromaticity, which describes the two-dimensional variation of colors that are orthogonal to the lightness. Well, artists have been using chromaticity to convey contrast for a long time. The 1820s saw the development of affordable blue pigments, which have been derived from precious jewels in the past. This led to much more experimentations with color. Impressionist painters were especially famous for using chromaticity in place of brightness contrast. Artists and art historians have recognized this trend, but did not quantify or name it. For example, Paul Cézanne explained of his work, "I want to do with color what they do in black and white." This can be seen in his famous painting, Mardi Gras, where the folds and the fabric details of a white outfit are depicted through subtle variations of chromaticity rather than lightness. We call this technique chromaticity mapping. The idea is to remap variations of lightness into variations of chromaticity. This technique can be so effective that we sometimes have a hard time recognizing that it's used, as we explored in our perceptual study described in our paper. One of the most extreme and famous examples of this technique comes from Monet's painting Impression Sunrise in 1972. Here, the strong contrast between the sun and the rest of the scene is almost entirely conveyed through chromaticity. This becomes more apparent if we visualize the lightness channel of the painting in CIE LAB color, which better approximate human perception of color. Here, the lightness of the sun is almost identical to the sky around it, demonstrating a remarkable understanding of the visual perception by Monet. We can understand this chromaticity mapping as a transformation of colors in the scene. Normally, converting an HDR scene to a LDR scene will reduce the range of different color values, resulting in a significant loss of contrast. With chromaticity mapping, the artists map this loss of contrast to variations in chromaticity to maintain high overall variation. This is very similar to how some data visualizations use chromaticity to increase the visual bandwidth of a color map. which can help viewers distinguish between a greater sorry, this animation, okay, it's playing now, can help us distinguish a greater variety in the data here. So how do we design a tool to help users apply the controls of this type in chromaticity mapping? For this, we need to answer 3 questions. First, how should we define contrast adjustments? Second, how should we map these adjustments to changes of chromaticity? And finally, how can we control what details in an image are enhanced by these adjustments? Let's start by looking at how existing tools deal with these questions individually. First, we'll look at one of the most common ways for users to manipulate contrast and the brightness of the image. One of the most standard tools for contrast adjustment is the curves tool. It is an expressive way to redistribute tonal contrast in an image, but it maps different lightnesses to values to change in lightnesses. And now we want to control changes in chromaticity. So how do we usually control contrast in chromaticity? The most common tool for this is saturation slider, which offers a 1D control over a 2D space of chromaticities. We can visualize the adjustment as shifting color values along a fixed 2D gradient field of chromaticities, which has a number of limitations. First, there's no way to create new color contrast. We can only amplify color contrast that already exists in the image. And second, this operation is independent of lightness contrast, so there's no way to express the kind of chromaticity mapping that we are interested in. And third, there's no way for users to choose what color palette they want to use to represent the contrast. To fix these issues, we really need to let the user control a custom 2D gradient field over this chromaticity space. So our solution, which we call chromaticity gradient mapping, involves 2 components. The first is an adjustment curve that maps input lightness values to changes in chromaticity. And second, a gradient curve that users can specify in chromaticity space. It controls a 2D gradient field for guiding the direction of color contrast. So once the user has defined those 2 components, we can adjust the image like this. And next, we will look at how to add selective detail adjustment to this method by filtering the lightness channel of the input image. In HDR photography, artists usually need to selectively enhance specific details in the post-processing tool. For example, this image shows the same image with contrast enhancements in the fine details of the rocks versus the global lighting. And we refer to our paper for more details in the related literature. By filtering the lightness channel of the image, we can transfer those types of detail enhancements in the chromaticity domain. So in the first row, we see that the contrast is applied as like the global lighting effect. We see the soft transition like across the rocks. And in the final row, we see that the fine details of the rocks are enhanced, while there's no such big global contrast in the color. And we can combine chromaticity gradient mapping with tone mapping operations and achieve this type of effect where the tonal detail is enhanced by in the lightness channel, and the global contrast is enhanced through chromaticity. And here I will show a quick demo of our application. So this is the interface of our tool. And on the left, we see the adjustment curve and the gradient curve. So we'll start by specifying the direction of the gradient that we want the colors to change along. And then in the adjustment curve, I can pull up this curve to shift the colors towards the warm side. And optionally, I can select a point in the image and then change its chromaticity by dropping up and down. It's equivalent to adjusting the curve here. So in this configuration, we enhance the global contrast of this image by spreading the chromaticities along the curve. And after this, we can also change the curve to see how this look in other color settings. And we offer additional controls over the detail levels, but due to the time being, I will not go over the details here. So return to my presentation. Here are some more results generated with our tool, and that's the end of my talk. Thank you, and please see our website for a link to the demo web app, and also more results, including detailed visualizations and some video results. And we also included results of our user study and the implementations in the supplementary material.
Hello, here's Alex from Singapore Management University, and very interesting work. Because I have a question is about right now you mentioned the nine-list contrast, what we call luminance contrast, and the chromatic contrast. And because we know from the human vision system, people are more sensitive to the nine-list contrast instead of the chromatic contrast. So when you are designing the system, would you find that, would you face some cases that where you trying to change the chromatic value, but it cannot reach the same contrast, perception contrast as the luminance? Did you face this situation?
Yeah, we also observed that in our perceptual study. So by alternating the chromaticity, we can slightly enhance the perceived contrast, but most of the details are still expressed in the tonal channel. But with our tool, sometimes users want to achieve the artistic effect like the impressionist painting, so they use like very strong saturation, and also they can like subtly adjust the color to give a hint of this perceptual effect. But I do agree that most details are still in the tonal contrast, and this is a supplement tool for that. So like in this example, we show that like most of the detail are effectively applied in the tonal channel, but we can still use the color to enhance this global contrast.
Oh, cool, thanks.